Hello everyone. Today let us solve some important problems on expression of hardness. For these problems, the required formulas were already explained in our previous video on expression of hardness. So let's begin. Problem number 1. A sample of water is found to contains following dissolving salts in milligrams per liter. Magnesium bicarbonate 73, calcium chloride 111, calcium bicarbonate 81, magnesium sulfate 40, magnesium chloride 95 milligrams per liter. Now calculate temporary, permanent and total hardness of water. Let us see the solution. In the solution, I have given as a tabular form. In the first column, I wrote name of the salt. In the second column, I wrote amount of the salt. In the third column, I have taken molecular weight of the salt. In the fourth column, I have applied formula. Already we know that the formula is amount of the salt into molecular weight of calcium carbonate by molecular weight of given salt. Formula: weight of the salt into molecular weight of the CaCO3 by molecular weight of given salt. In the table, in the first column, write all the salts given in the problem. First salt, magnesium bicarbonate. Second salt, calcium chloride. Third salt, calcium bicarbonate. Here fourth, magnesium sulfate. And fifth, magnesium chloride. In the second column, amount of the salt, weight of the salt. For magnesium bicarbonate, 73 is given here. And calcium chloride, 111. Calcium bicarbonate, 81. Magnesium sulfate, 40. And magnesium chloride, 95. Now you have to write molecular weights of given salts. Molecular weight of magnesium bicarbonate is 146, calcium chloride 111, calcium bicarbonate 162, magnesium sulfate 120, magnesium chloride 95. Coming to first salt, magnesium bicarbonate. Weight of the salt is 73, molecular weight of calcium carbonate is 100, and molecular weight of magnesium bicarbonate is 146. Now this formula will be 73 into 100 by 146. We will get 50. The last column, 73 is weight of magnesium bicarbonate, 100 is molecular weight of calcium carbonate, 146 is molecular weight of given salt. So we will get 50. Coming to next salt, calcium chloride. Weight of the salt is 111 and molecular weight of calcium carbonate is 100 by molecular weight of given salt, that is the calcium chloride molecular weight 111, we will get 100. Coming to third salt, calcium bicarbonate. Here weight of the salt is 81 into 100 molecular weight of calcium carbonate by molecular weight of calcium bicarbonate is 162. So we will get 50. Coming to next salt, magnesium sulfate. Weight of the salt is 40 into molecular weight of calcium carbonate is 100 by molecular weight of magnesium sulfate, that is 120. So we will get 33.3. And next, magnesium chloride. Weight of the salt is 95 into molecular weight of calcium carbonate is 100 by molecular weight of magnesium chloride is 95. So we will get 100. Then separate out whatever the temporary hardness producing salts and whatever the permanent hardness producing salts given in a problem. Temporary hardness producing salts: magnesium bicarbonate, calcium bicarbonate. So now write here magnesium bicarbonate formula plus calcium bicarbonate formula. That is equal to, what is the hardness of magnesium bicarbonate? We got 50. So 50 plus, what is the calcium bicarbonate hardness? We got 50. 50 plus 50 is equal to 100 milligrams per liter. This is the temporary hardness of water. And coming to permanent hardness producing salts are calcium chloride, magnesium sulfate, and magnesium chloride. Now write hardness of these three salts. First write the formulas. Permanent hardness is equal to calcium chloride plus magnesium sulfate plus magnesium chloride. That is equal to calcium chloride hardness. We got 100 plus magnesium sulfate hardness. Magnesium sulfate we got 33.3. Now magnesium chloride hardness we got 100. That is equal to 100 plus 33.3 plus 100. We got 233.3 milligrams per liter. So this is permanent hardness of water. Now we require total hardness of water. Total hardness is equal to temporary hardness and permanent hardness. Temporary hardness we got 100. Permanent hardness we got 233.3. 233.3 here. Then 100 plus 233.3 is equal to 333.3 milligrams per liter. This is total hardness of water. Now let us see second problem. Problem number 2. A sample of water is found to contains following dissolving salts in milligrams per liter: magnesium bicarbonate
16.8,
magnesium chloride 12, magnesium sulfate 29.6, sodium chloride 5 milligrams per liter. Now calculate temporary and permanent hardness of water. In the solution I have given same tabular form as previous one. So in the first column, name of the salt; in the second column, amount; third column, molecular weight; fourth column, formula. Coming to formula, amounts equivalent to calcium carbonate is, it is equal to amount of the salt into molecular weight of CaCO3 is 100 by molecular weight of given salt. Now formula, amounts equivalent to calcium carbonate is equal to amount of the salt into molecular weight of calcium carbonate is 100 by molecular weight of given salt.
here first salt magnesium bicarbonate,
Second salt magnesium chloride, and third magnesium sulfide, and fourth sodium chloride. In the second column, weight of the salts: magnesium bicarbonate 16.8, magnesium chloride 12, magnesium sulfate 29.6, sodium chloride 5. Now you have to write molecular weight. Magnesium bicarbonate 146, magnesium chloride 95, magnesium sulfate 120. And sodium chloride, no need to write about sodium chloride because sodium chloride does not contribute any hardness to water. So don't do calculation for sodium chloride. Now substitute these values in the formula. Now let us see. Magnesium bicarbonate weight is 16.8, here 16.8, into molecular weight of CaCO3 is 100 by molecular weight of magnesium bicarbonate is 146. So we will get 11.50. Coming to magnesium chloride, weight is 12, molecular weight of CaCO3 is 100, molecular weight of magnesium chloride is 95. So we will get 12.63. Coming to magnesium sulfate, weight of the salt is 29.6 into molecular weight of CaCO3 is 100 by molecular weight of magnesium sulfate is 120. So we will get 24.66. Then separate out temporary hardness producing salts and permanent hardness producing salts. In this problem, only one salt, that is the magnesium bicarbonate, is temporary hardness producing salt. You can directly write 11.50 milligrams per liter, that is temporary hardness. Coming to permanent hardness producing salts are two. One is magnesium chloride, another one is magnesium sulfate. So permanent hardness is equal to magnesium chloride plus magnesium sulfate. Here magnesium chloride hardness is 12.63 and magnesium sulfate hardness is 24.66, and then 12.63 plus 24.66, that is equal to 37.29 milligrams per liter. So this is the permanent hardness of water. Now let us see third problem. A sample of water is found to contains following analytical data in milligrams per liter: magnesium bicarbonate 14.6, magnesium chloride 9.5, magnesium sulfate 6, calcium bicarbonate 16.2. Calculate temporary and permanent hardness of water in parts per million, that is ppm, degree Clarks and degree French. Coming to solution, same tabular form. In the first column, name of the salt. Second column, weight amount of the salt. In the third, molecular weight of given salt. In the fourth, formula. So formula, already we know that amounts equivalent to calcium carbonate is equal to weight of the salt, that is amount of the salt, into molecular weight of CaCO3 is 100 by molecular weight of given salt. Note down the salts: magnesium bicarbonate, magnesium chloride, magnesium sulfate, and calcium bicarbonate. And weights of the salt: magnesium bicarbonate weight is 14.6, magnesium chloride 9.5, magnesium sulfate 6, calcium bicarbonate 16.2. Now you have to write the molecular weights of given salts. 146 is magnesium bicarbonate molecular weight, magnesium chloride 95, magnesium sulfate 120, calcium bicarbonate 162. Now substitute all these values in the formula. Coming to first salt, magnesium bicarbonate. Weight of magnesium bicarbonate is 14.6 into molecular weight of calcium carbonate is 100 by molecular weight of magnesium bicarbonate is 146, and simplify this we will get 10. Magnesium chloride, weight of the salt is 9.5, molecular weight is 100, calcium carbonate molecular weight, by molecular weight of given salt. The magnesium chloride molecular weight is 95, so we will get 10. Coming to magnesium sulfate, weight of the salt is 6 into molecular weight of CaCO3 is 100 by molecular weight of salt 120, we will get 5. Coming to magnesium bicarbonate, weight of the salt is 16.2 into 100 by 162 is molecular weight of calcium bicarbonate, we will get 10. Now separate out temporary hardness producing salts and permanent hardness producing salts. Temporary hardness producing salts are magnesium bicarbonate, calcium bicarbonate. Then write magnesium bicarbonate plus calcium bicarbonate. For magnesium bicarbonate, we got 10 ppm. For calcium bicarbonate, hardness we got 10 milligrams per liter. 10 plus 10, that is equal to 20 milligrams per liter. So this is the temporary hardness. Already we know that 1 milligram per liter is equal to 1 ppm. So here 20 milligrams per liter is equal to 20 ppm, and convert into Clark's degree. 1 ppm is equal to 0.07 Clark's degree. So 20 into 0.07 Clark's degree, we will get 1.4 Clark's degree, and then convert into French degree. 1 ppm is equal to 0.1 French degree. So 20 into 0.1 French degree, that is equal to 2 French degree. And coming to permanent hardness producing salts are magnesium chloride and magnesium sulfate. Then write the formulas: magnesium chloride and magnesium sulfate. Magnesium chloride hardness is 10 milligrams per liter. and magnesium sulfate hardness is 5 milligrams per liter. So 10 plus 5, 15 milligrams per liter. So already we know that 1 milligram per liter is equal to 1 ppm. So 15 milligrams per liter is equal to 15 ppm. And already we know that 1 ppm is equal to 0.07 Clark's degree. So 15 into 0.07, so we will get 1.05 Clark's degree. And 1 ppm is equal to 0.1 French degree, that is equal to 1.5 French degree. In the question, they asked that calculate temporary permanent hardness of water in parts per million, degree Clark's and French degree. So that is the reason for conversion of milligrams per liter into ppm, Clark's degree and French degree. Now I am giving you a problem. Try to solve it and write your answer in the comment section. Calculate the amount of temporary and permanent hardness of water sample in degree Clark's, degree French and milligrams per liter, which contains following impurities: calcium bicarbonate 121.5 ppm, magnesium bicarbonate 116.8 ppm, magnesium chloride 79.6 ppm and calcium sulfate 102 ppm.
Thanks for watching. Like, share, subscribe for more videos.